given two sets A and B, so say you're given two sets A and B, their Cartesian product is denoted by A times B. And this is the set. A times B is, you write it as a tuple A comma B. So the first element belongs to set A and the second element belongs to set B. So let us do an example. So say set A is 1 comma 2 and set B is A, B, C. Then A times B would be, so you first fix first element of set A1. So you have 1 comma A, you have taken 1A, then 1 comma B, 1 comma C. Then you fix element 2 of set A, and then you have 2 comma A, then 2 comma B, and then you have 2 comma C. Now if number of elements in A is n and number of elements in B is m, then the number of elements in A times B, that is the Cartesian product, would be m times n. So for example, here number of elements in A is 2, just 1 and 2. Number of elements in B is 3. So the total number of elements in A times B, that is the Cartesian product of A and B, is 6. So 1, 2, 3, 4, 5 and 6. So in particular, if A or B is a null set, then this A times B is also a null set. This you can also see from the formula. In that case, if A is say a null set, then number of elements in A would be 0. So number of elements in A times B would also be 0, and a null set has 0 number of elements. Another example is the two-dimensional plane. So this is Cartesian product of real numbers. So in two-dimensional plane you have x-axis and y-axis, and both of them are real numbers. So this is how the two-dimensional plane looks like. You have the x-axis and you have the y-axis. So all real numbers here and all real numbers here. So you have this entire plane. So two-dimensional plane is this entire plane. Now we talk about relations. Relation is nothing but a subset of Cartesian product. For example, so if you are considering this two-dimensional plane, the first quadrant of two-dimensional plane can be seen as a relation. So this is the entire two-dimensional plane. You have the x-axis here and you have the y-axis here. Now if you just focus on the first quadrant, so this is the first quadrant. So from the entire plane you're just focusing on the first quadrant. So this first quadrant is a subset of the entire plane, and we can describe this first quadrant using a relation, and the relation is you have x comma y. X is a positive number and y is a positive number. So you know that if you pick up any point here in the plane, say 2 comma 3, so both the coordinates, the x coordinate and the y coordinate, are positive. So this is a relation. So relation is nothing but a subset of a Cartesian product. For example, consider this relation a1 times b1. This is a subset of a times b. So we are talking about a relation which is a subset of a Cartesian product. So a1 would be a subset of a and b1 would be a subset of b. So we are now describing what a relation is. So relation is nothing but a subset of Cartesian product, and now I'm specifically saying that a1 is a subset of a and b1 is a subset of b. So we call a as the domain and this b1 as the range of relation R. B is the codomain of R. So let us just quickly recap. So relation is nothing but a subset of the Cartesian product. So you have a1 is a subset of a, b1 is a subset of b. You call a as the domain of the relation, b as the codomain of the relation, and b1 as the range of the relation. Now we do a concrete example. So say you have a set A. So set A has 4 elements, 1, 2, 3, 4, and we want to define a relation on A. So defining a relation on a set A means we are going to talk about a subset of Cartesian product of A times A. So let us define this relation. So relation would be a comma b, b is equal to a plus 1. So this relation is a subset of a times a. So it is something like the form a1 times a2. So where a1 is just 1, 2, 3 and a2 is just 2, 3, 4. So let us see this in an arrow diagram, that why. So we had this entire set 1, 2, 3, 4, but now I am saying the relation here is just this set 1, 2, 3 and a2 as 2, 3, 4. So let us see this. So relation is a Cartesian product, but we are going to draw it as an arrow diagram. So you have set A here, and we again write set A right here. So the relation is nothing but bunch of arrows going from set A to set A. So in A we have 1, 2, 3, 4. You have 1, 2, 3 and 4. Similarly here you will have, this is set A, you will have 1, 2, 3, 4. So relation is defined on A times A. So this is first A is right here, the second A, this one is right here. So the relation is this B, that is the second set, this B is this set, this A is this set, this B is equal to A plus 1. So element here is plus 1 element here. So if you add 1 to 1, you get 2. You add 2 plus 1, you get 3. 3 plus 1, you get 4. Four plus 1 is 5, but it does not lie in A. So there is no arrow coming out of 4. Similarly, 0 plus 1 is 1, but there is no 0 in A. So there is no arrow going into A. So this part is called domain. This A is called domain. This A is called codomain. These elements 2, 3, 4 are called the range. Notice that 2, 3, 4 is nothing but A2. And what is A1? A1 is 1, 2, 3. This is A1. So relation is precisely the set of arrows. So relation goes from A1 to A2. So therefore you can write this relation as this tuple. Your first element is 1, 2, that is, you're talking about this arrow. Then the second relation is 2, 3. The third one is 3, 4. So all these three are nothing but 3 arrows. So this is the relation. So this is a relation, and this is a subset of A times A. So this is a subset of A times A. Obviously A times A also consists of 1, 1. It also consists of 1, 4, and those parts we are not considering. So relation is a particular subset, and we have described this relation by this particular argument, that B is equal to A plus 1. Now last thing and very important thing is that these elements 2, 3, 4, where the arrow lands, so arrow is landing in 2, 3 and 4. These 2, 3, 4 are called image. And the arrow starts from these points 1, 2, 3. So the starting points of the arrow are called pre-image. So you could see this directly in the relation also. This is the first element is the pre-image. This is the pre-image, this is the pre-image, and the second element is the image. So this is the image, this is the image, and this is the image. So here again A and B. B is the image, A is the pre-image. So that is the entire story behind relations. And relations are important because we define functions further as a subset of relations.